Hi everybody, this is Miss McClellan here to go over IM2 Notes 3.1.5 with you. How much can I expect to win? Today we have two learning goals, and we'll write them in the first person. Number 1, I will be able to, this is number 1, calculate the expected value of games of chance. And number 2, I will be able to use expected value to determine if a game is fair. Okay, we start with problem 3-47. Take a spin. Consider the following game. After we spin the reel at right, we win the amount spun. The wheel is right here. Part A. If you play the game 10 times, how much money would you expect to win? Let me think. I'm going to land on 4 about half of the time. I play 10 times. I think that means I'd land on 4 about 5 times. 4 times 10, but 10 times a half. So that equals $20. I think I'd win about $20. Wait, is that right? No, it should be 25. Nope, 20. Okay, here we go. Continuing. What if we play 30 times? Well, that's 30. I think I'd win about half the time. And that would be multiplied by 4. So 15 times 4. I think I'd get about $60. 100 times? Okay, well that's 100 times. I'm going to land on 4 about half the time. So that's about $200. We did our calculations by multiplying the number of times we play by the probability we win by the $4 amount. So how much do you think we would win on average? That's saying, okay, so if in 100 games we win $200, let's see, 100 games, 2 equals $200, then I think one game should equal about $2. If I were to play only once, I would expect to win, according to the method we did in part A, that was one game times 1/2 times $4. Yeah, that equals $2. But that's some nonsense, because I can't land on $2. So even though that's my expected winnings, it's actually not possible to win that amount. And I know because I can only land on $0 or 4. $2 is not an option. So you should be asking yourself, if I can't win $2, what is this conversation about? And keep that question in your mind. Hold it with you as we continue, because these notes are an attempt to answer it. Okay, now we have a new spinner. What if the spinner looks like this one? How much would we expect to win after 8 spins? Let me think. Well, I think I'd get $0 about half the time, so $0 times half the time. I think I'd get $4 about a fourth of the time. And I think I'd get $100 about a fourth of the time. And I'm going to play 8 times. So let me think, what's that? That's 8 times 0 plus 1 plus 25. That's 8 times 26. Okay. All right, let's see. That's $208. And what if I played 100 times? Well, most of this calculation would be the same, except I'd have 100 times 0 plus 1 plus 25. So that would be 100 times 26. So that would be 26 with 2 zeros. All right. So what am I doing? I'm multiplying the number of times I play by the amount I would expect to win if I only played once, even though it's not possible to actually get that amount. This is what this inner part right here, this part, that has a special name. It's called expected value. The expected value would be 0 times the amount of how often I'd expect to land on 0, which is about a half of the time, plus 4 times how often I expect to land on 4, which is about half the time, plus 100 times how often I expect to land on 100, which is about a quarter of the time. I think I said half right here. I meant to say a quarter. And that equals $26. The expected value is $26. Okay, let's look into that one more time. Gustavo described his thinking for part B in this way. Half of the time he earns $0, quarter of the time he earns $4, a quarter of the time he earns $100. So for one spin, Gustavo expects to win $26. That's what this whole thing equals. And this result does match our previous answer because we did it the same way as Gustavo. Okay, now we've got another problem. 3-49. This one's about Jesse. Jesse has created the spinner down here. This time, if we land on a positive number, oh gosh, there's going to be so much to keep track of here. Positive number, we win. If we land on a negative number, we lose. Let's see if this is a good idea to play. Do we think that somebody would lose money if they played a lot of times? I'm not sure. Well, it looks like they would lose half the time. and win half the time. But they could win $8 or lose $7. But -5 is the most likely outcome because it's the biggest part of the circle. I'm not sure. I'm not sure if this is a good deal or not. Let's calculate the expected value because that could give us a really good idea. So let's see. I see this as $6 times a quarter of the time plus $2 times 1/4 of the time plus, or rather minus, because it's -$2, minus $2 times, let's see, that's 45 degrees. 45 degrees is 1/8 of the circle, so I'd lose $2 about 1/8 of the time. And I'd lose $5 about 3/8 of the time. Now you can either use a calculator or you can do this with common denominators. I'm going to go common denominators. So this would be 6 times 2/8 plus 2 times 2/8 minus 2 times 1/8 minus 5 times 3/8. I'm doing it by hand simply because I don't feel like getting a calculator, but you are very welcome to use a calculator. So this becomes 6 times 2 plus 2 times 2 plus, minus 2. And I'll zoom back in. And minus 5 times 3, all divided by 8, which is equal to 12 plus 4 minus 17 all over 8, which is equal to -1 over 8. So my expected value is -$0.125. Now, clearly that's not one of the possibilities, but it's an average. It's allowed to not be one of the options on the spinner. I'm going to lose money on this game probably. I don't want to play it. Okay, part C. If a game involving probability is fair, what does that mean for the probability of winning and losing? Well, in this class, that means that you need a 50-50 chance. A 1/2 probability of winning and losing. What does it mean for a spinner to be fair? Same. You need to be equally likely to win and lose. If a game involving money is fair, the expected value should be $0 equals expected value for a fair game. You are expected to know this, wonderful students. Let's highlight it. So if I'm asking you to calculate what one piece of a spinner has to be in order for the game to be fair, You do your calculation for expected value and set that equal to 0. Okay. That'll make more sense when we do a couple examples below. Okay, this game is called Double Spin. It's a new game. If the player gets to spin twice, but only wins if the same amount comes up both times. So like if we were rolling a dice, you would only win if you got doubles, if you were rolling 2 die. Okay, we're going to use an area model or a tree diagram to show the sample space and probability of each outcome. We're only playing 2 times, so I'm going to use an area model. So let's think. Okay, I'm going to make up a spinner for this just because I forgot to put it in the notes and I think I can make a fine problem. So this is 1/8. So 100, and I'll say the rest is 1. Okay, so you could either spin 100 or you could spin 1, and we're going to spin twice. First spin, second spin. So 100, 100, 1, and 1. This is going to be 1/8. So the 1 has to be 7/8. 1/8 and 7/8. So the probability of spinning 100 twice is 1/64. That's the probability of spinning 100 and 100 again. The probability of spinning 100 and then 1 is 7/64. The probability of spinning 1 and then 100 is again 7/64. And the probability of spinning 1 and then 1 is 49/64. So that's the sample space and the probability of each outcome. Okay, what is the expected value when playing this game? Let's see so we win if we get 2 1s, because you have to get the same thing twice, and we win if we get 2 100s, and we lose, as in get nothing, for the other 2. So let's see, this is going to be, I get $100 1/64 of the time. I get $0 7/64 of the time. There's another way to get $0. It's also 7/64 of the time. And I get $1 49/64 of the time. So that equals 100 plus 49 divided by 64. That's 149 over 64, and it's worth it to me to get a calculator this time. So this expected value is about $2.33. That's if the game costs nothing to play. As soon as the game costs more than $2.33, the odds are no longer in my favor. All right, let's continue. If it costs $3 to play this game, should we expect to break even in the long run? Well, no, because the amount I have to pay would be more than I expected to win. Since $2.33 is less than $3. Is the game fair? No. The expected winnings are not $0. Okay, we continue. This is just some practice problems. Number 353. The central angle of region A is 7 degrees. Let's calculate the expected value of one spin. And answer, is the game fair? So that means we have the probability of region A is 7 divided by 360 degrees in a circle, everybody. The probability of region B is 360 minus 7, 353 degrees divided by 360. So my expected value equals 100 times 7 over 360 plus 2 times 353 over 360. And again, it's worth it to me to go get a calculator for this. It equals 3.91. The expected value, which is not 0. The expected value is not 0. So the game is not fair. Okay, next problem. This game is fair. Therefore, the expected value equals 0. So I'm going to have $2 times 3/4 plus, I don't know what x is, but x dollars times 1/4, and that's going to equal 0. So that gives me 6 plus x over 4 equals 0. X has got to be -2. Wait. Just kidding. X has to be -6. Ha 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 ha. I need the numerator to be 0. All right, we continue. 354. Determine the value of x so that the expected value of the spinner is 3. Okay, I'll set up my equation. Okay. This is less obvious for me to look at probability-wise, so I'm going to do probability of -3 equals 60 over 360. And let's see, what's that equal? 0.6 repeating. The probability of 1 is 60 over 360, which is also 0.6 repeating. And the probability of x is, I don't know, 360, 300, 240? No. What's 360 minus 60? 300. What's 300 minus 60? 240. Yeah, okay, so 240 over 360. And that equals, let me just think for 1 second. 0.6 repeating, and I got the upper two ones wrong. These should each have been 1, 6 repeating, 1, 6 repeating. So the expected value is 3. So 3 is what equals -3 times 0.16 repeating plus 1 times 0.16 repeating plus 200, plus x times 0.6 repeating. So that equals, using my calculator for this part, negative 0.3 repeating plus 0.6 repeating x. I add 0.3 repeating to both sides. I get 3.3 repeating equals 0.6 repeating x. I divide both sides by 0.6 repeating. And I get that x is equal to 5. Okay, next problem. Determine the value of x so that the expected value of the spinner is 3. Here we go. Okay, the probability of 18 is 40 over 360. The probability of 9, well, this is a straight line angle, so 140 plus 40 equals 180. So 9 has probability of 140 over 360. Negative 3, the probability of that is 1/4, and the probability of x is 1/4, and the expected value is 3. So 3 equals 40 over 360 times 18 plus 140 over 360 times 9 plus 1/4 times negative 3 plus 1/4 times x. I'll throw this part into my calculator because it's just a straight number. To get 3 equals about 4.7472 plus 0.25x. Subtract 4.7472 from both sides. I get negative 1.7472 equals 0.25x. Divide both sides by 0.25. And I get x equals negative 6.9 with the 8 repeating. Woo! Hope I didn't make any mistakes. Let's keep going. 3.1.5 math notes. Expected value. Okay, here we go. The definition of expected value. The expected value of a game is an average result expected to be won or lost on exactly one play of a game, and it equals whatever the region's value is times the probability of that region plus all of the other regions multiplied by their respective probabilities. The amount you would expect to win or lose per game after playing a game of chance many times is called the expected value. And this should have said win or lose on average. This value does not need to be a possible outcome of a single game, but instead reflects an average amount that will be won or lost per game. So for example, the $9 portion of the spinner at right makes up 30 degrees out of 360, so 1/12 of the spinner, while the $4 portion is the rest, so 11/12. So the expected winnings for the game for 12 spins would be 1 times 9, because you expect to land on 9 one of those times, plus 11 times 4, because you expect to win on 4 11 of those times, equals $53. If you play the game a lot, you'd earn an expected value of $53 divided by 12 spins per game. So that would be like 442. You can use this value to estimate the result for any number of spins. So, for example, if you play 30 times, your expected winnings would be 30 times $4.42 is $132.60. Another way to calculate expected value involves the probability of each possible outcome. So since 9 is expected 1/12 of the time and 4 is expected 11/12 of the time, the expected value can be calculated with the expression 1/12 times $9 plus 11/12 times $4, and that ends up also equaling $4.42. A fair game is one in which the expected value is 0. That is, a game is called fair if over many, many plays, a person would expect to neither win nor lose points or money by playing the game. Thank you for coming along with me on this journey. I hope you have a great day, and I'll see you next time.